For problem number 9, I'm going to solve it using the elimination method. I see that it's already in standard form and set up for that, and I'm going to look at canceling out my y's. Now, when I choose which one to cancel out or which equation to use multiplication on, I'm going to know I'm going to need to multiply by a -1 somewhere. And noticing that the first equation has a bunch of negatives in it, I'm going to multiply that equation by -1. And that will be rewritten as a positive 7x plus a positive 2y equals a positive 13. And then I'm just going to copy that second equation below it. And then all I need to do is add them. So that gives me 8x, these will cancel, is equal to 24, divide by 8, and x equals 3. Then I will just plug that into one of the equations to solve for y. And I'm going to use the second equation, again, going back to the original because that first one, it just has a lot of negatives in it. So that leaves me with 3, because I'm substituting in that x, minus 2y equals 11. Then I'll minus 3, negative 2y equals 8, divide by -2, divide by -2. And y is equal to -4. Again, check this with your calculator. You guys can do that. I'm not going to go through that long check progress by hand, but you know what to do. Plug in your x for 3 and your y and -4 and work out that equation. Same thing for the first one as well. For this problem, I am going to use, you could use the graphing method. I don't have a graph right now on this page, so what I'm going to do is the substitution method. Now, when I do that, I can end up just setting these two equations equal to each other because I can substitute those y's for one another. So that leaves me with 1/2 x plus 5 equals -5 over 2x minus 1. I'm going to add 5 halves to both sides. 5 halves x. And I'm going to subtract 5 over here. So that will cancel here and cancel here. And that'll leave me with, that's 1/2 plus 5 halves gives me 6 halves, which is the same as 3. So 3x is equal to -6. Then I'm going to divide by 3, and that will leave me with x is equal to -2. Then I'll substitute that into one of the equations. I'm going to choose that first one just because I know it's a 1/2 and half of 2 is a 1. So I'll have y equals 1/2 times a -2 plus 5. And that'll be y equals -1 plus 5. So y is equal to 4. Again, you guys are always checking these. You have your calculators right in front of you. So you'll just substitute in these two variables, and that will give you your answer. Lastly, on this problem, I'm going to use the substitution method again because it's already solved for one of our variables. And we're thinking back to that foldable we used in class, or not the foldable, but what we glued into our notebooks on the best method to use which method when. So when I see a y in the first equation, I'm going to plug in the -4 over 3x minus 1. So I have 5 times -4 over 3x minus 1 is equal to 8x minus 5. And I'll have -20 over 3x minus 5. If you're not good with fractions, please, please, please just type it into your calculator. And this is equal to 8x minus 5. I'm going to minus 8x and minus 8x. And then I'll add 5 at the same time. These will cancel, and we notice that these will cancel, but what's left over here is a 0. It's not nothing, it's just, you'll put a 0 in its place. And a negative 20 over 3x minus 8x, so that's the equivalent to negative 24 over 3. So that's a negative 44 over 3x is equal to 0. So if I times by 3 over negative 44, those will cancel. Or if I just divide by a negative 44 over 3, divide by a negative 44 over 3, I just know that x is going to be equal to 0. Then I'm going to take that and I'm going to plug that into the second equation because it's already solved for y by itself to solve for that y. So I will have y equals negative 4/3 times 0. I'm substituting the x right here in for the x up here, minus 1. These will cancel, and it'll be y equals negative 1. Again, you're always checking, and then we will put that ordered pair. 0, negative 1. And again, that was the substitution method.